So today, we're diving into something you've probably never heard of, but it quietly shapes our entire future. It's this unseen blueprint for global innovation, and we're about to pull back the curtain and see exactly how it all works.
I mean, think about it. You see these headlines all the time, right? Countries ranked by how much they spend on R&D or their scientific breakthroughs. But how can we actually trust those numbers? How do we really, truly know who's leading the innovation race?
Because that's the heart of the issue, isn't it? Without a common standard, it's just chaos. One country's pioneering research could be what another just calls routine product updates. It's like trying to compare apples and oranges. If the oranges were also claiming to be apples, you absolutely need the same ruler for everyone.
And that's where our unsung hero comes in, the Frascati Manual. It's basically the universal translator for the language of innovation. Put together by the OECD, it creates a single standard way for the entire world to define, classify, and measure research and development.
And this thing isn't some dusty old document either. It's a living guide. It started way back in 1963 in a town called Frascati in Italy. And as the world's economy changed, so did the manual, getting big updates in the 90s for the new knowledge economy, and again in the 2000s to get a better handle on the booming service sector.
So here's our game plan. We're going to tackle this in 4 simple parts. First, what actually counts as R&D? Then, who's doing it? Third, how in the world you measure it? And finally, the big one, why should you even care?
All right, Section 1. What counts as R&D? This is maybe the manual's most important job, drawing a really clear, bright line in the sand between what is genuine R&D and, well, everything else that just kind of looks like it.
And here it is, the core definition. Now, don't just skim it. The key words are everything. It has to be creative, meaning there's some novelty, something new. It has to be systematic, so it's not just a lucky guess. It's a planned process. And the goal? Well, it's either to increase our stock of knowledge or to figure out new applications for the knowledge we already have. Now, this is where it gets really interesting. The manual says R&D isn't just one thing. It's actually a spectrum broken down into 3 distinct types. You can think of it as a journey, really, from a pure abstract idea all the way to a real, tangible thing.
So, first up, we have basic research. This is pure what-if science. It's all about curiosity. Picture a scientist in a lab just trying to figure out how the universe works with zero thought about a specific product. You know, mapping the structure of a molecule. That's a perfect example. It's just knowledge for the sake of knowledge.
Okay, next on the journey is applied research. This is where we take that basic fundamental knowledge and point it directly at a specific problem we want to solve. We're not just mapping antibodies for fun anymore. Now we're trying to use that info to tell the difference between the antibodies for disease A and disease B. See, there's a very clear, practical goal.
And finally, we get to experimental development. This is where the rubber really meets the road. It's all about taking what we've learned from research and systematically turning it into something new. A new material, a new device, a new process. Creating a synthetic antibody based on all that prior research and then actually testing it on patients, that's it. That's innovation in action.
Okay, so that covers the what. Now for Section 2. Who is actually doing all this R&D? The manual has a system for that, too.
It neatly sorts all this activity into 4 main buckets. You've got the business enterprise sector, that's basically all the companies out there. Then there's the government sector, doing research for public services. You have higher education, all your universities and colleges. And last, the private nonprofit sector, so think of big foundations or research charities. This system makes sure that when we compare R&D in, say, Japan and Germany, we're actually comparing apples to apples.
So we have the what and the who. Now for the tricky part. Section 3. How do you actually measure all this? How do you put a hard number on something as fluid as innovation?
And this is a really crucial point. The Frascati Manual does something very clever. It doesn't even try to measure the outputs of innovation, like inventions or discoveries, because that's almost impossible to standardize. Instead, it focuses purely on the inputs. And that boils down to 2 simple things: the people working on it and the money being spent.
Now, when you're counting the people, you've got 2 main options. You can sort them by their formal degrees, how many have PhDs, or you can sort them by their actual job function. Are they a researcher, a technician, or support staff? The manual prefers a person's job function because the role of a researcher is pretty similar everywhere, while what it takes to get a specific degree can vary a lot from country to country.
But what about people who don't spend 100% of their time on R&D? Think about a university professor who has to teach classes and also run a lab. The manual has a brilliant solution for this called the full-time equivalent, or FTE. It's just a clean way to standardize how we measure effort.
And here's the perfect example. Let's say a scientist spends exactly half her working hours over a year on R&D projects. She doesn't count as one person. She counts as 0.5 FTE. It's a simple trick, but it allows for incredibly precise comparisons of how much human effort is really going into innovation.
And what about the money side? This chart is absolutely fascinating. Just look at this breakdown. You've got labor costs and other current costs, things like supplies and utilities, making up almost 90% of the entire budget. It's a powerful reminder that R&D isn't just about shiny, expensive machines. It's mostly about paying smart people to think and solve problems every single day.
So, we've gone through the what, the who, and the how. But that brings us to our final and maybe most important question. Why does a nerdy manual full of statistical rules actually matter in the real world?
Because this data becomes the bedrock for huge decisions. For a government, it means they can stop guessing and start strategically investing taxpayer money into the fields that are going to create the industries of tomorrow. For a business, it means they can benchmark themselves against their global competitors and make smarter choices. And for all of us, it gives economists the reliable data they need to understand what actually drives economic growth and a better quality of life.
At the end of the day, the Frascati Manual is so much more than a rulebook. It's the invisible grammar, the shared vocabulary that lets the entire planet have one coherent, intelligent conversation about progress. It allows us to tell the story of innovation with numbers that we can all actually understand and trust. But that leaves us with one final big question. This manual has been evolving for more than 60 years, but with revolutions in AI and biotech happening at what feels like light speed, the very nature of discovery is changing under our feet. So the question we have to ask is, as the world transforms, how must our ruler, our very way of measuring progress, change right along with it?